Well, good afternoon, everybody. Again, I'm very pleased to be able to talk to you. With the current situation, it's a bit like home alone for me. So today, the health and safety and wellbeing aspects of my talk really come down to trying not to contaminate the environment and people with some of the materials that have been used on the highways in past years. The main problem with old highway works is that there is a material called tar in them. So I'll talk about that. I'll then give some information about where it might be located within the highway and the current guidance and advice and different strategies that people use to ensure that it doesn't cause harm to the environment or can and doesn't actually go to waste, because obviously an environmental issue is you don't want to dig up usable construction materials and put them in landfill or burn them. So where they can be reused, that's the essence of what we want to be doing. The definition of tar there is been around for a long time. It's a byproduct of coal gas or coke manufacturer. And in the European Waste Catalogue, they've got a description of asphalt waste containing coal tar, AWCCT. Well, asphalt waste a lot of it's got bitumen in it, and the coal tar that is in the asphalt is not actually coal tar. It's this one here, crude tar. And it produces, it's a product from the coke and coal gas industries, all these coal plants that we used to have in towns to produce town gas, produced coal tar. And Mr. Pooley, I think his name was, the county surveyor of Nottingham, invented a material called tar macadam many years ago, because there was a lot of dust from horses and carts. And they sprayed tar on the roads to keep the dust down. And then he developed a material where you put aggregate in it as well. And he invented tarmac. So road tar's been used on the highways for a long time. But it's not the same as coal tar, which is a bit of a sticking point for me, because a lot of the risks and hazards have all been assessed on coal tar. And when road tar is produced, it's actually heated, and a lot of these lighter oil fractions, which cause the damage to humans and the environment, get lost. So there was actually a British standard to make this stuff. So it was nowhere in years gone by was it deemed to be a waste as such. Obviously, people were careful not to eat it because obviously it's not very good for you. But we used to add it to soap, and there's a very good antibiotic soap, Wright's coal tar soap, that was about for years. So there's a mixed message here in whether it's good or bad, and some people actually like the smell of asphalt and think it does them good. Oh, good job, we're all different, that's all I can say. But there were lots of different grades, and as you can see, it's all over the place. The biggest problem we've got is that you can't actually identify the difference between tar and bitumen very easily, because they've all got polyaromatic hydrocarbons in them. So you've got to do some testing to identify it. So it's been used for grout, in asphalt, surface dressing. In fact, tar bit dressing was used into the mid-80s, so it's quite high up in the pavement. And even today, I think for certain aspects where you've got the need to have fuel-resistant surfacing, there might be some tar used even today at these specialist applications. And it's reckoned that there's quite a lot out there. So what is the problem with it? Some PAHs are known to have carcinogenic effects. It can be hazardous to aquatic life. And as I said, it's classified as a hazardous waste if the level of tar in it is too high. So you use a typical road, you dig a hole in it. This is particularly interesting because the old road underneath was made with these great big stones, so that could well have been an old Roman road under there. And as you can see, the current construction is pretty thin relatively. So when they want to do any work on this road, they would probably dig all that lot up, and there's virtually a reconstruction project going on. And if you look at this close-up of the road, so this layer here looks particularly shiny. Which is indicative of a tar-bound material. But as I said, to do the reconstruction, you're probably wanting to remove all this material from bottom to top. So when you're looking for tar, what do? Do you just take a sample from there? Or do you take a sample from the whole lot? But it really depends what you're trying to do. And if the design of the works is to remove all that layer, then the horizons that will come from the works is the whole lot mixed up, because you can't really separate it. You'd stick a road planer in there and you'd have the whole lot out. So you need to characterise the horizons. So you don't really want to look for the tar. So if you take a little sample of that material there, it will give you a value of PAH, which makes it hazardous, and you get yourself into a right pickle, because you're not looking to find tar, you're looking to characterise the horizons for the construction project. So typically you don't do trial pits like that. You end up with a core, and you can see the different layers in here. And if you're clever enough, you can see lots of layers. And each one of them may or may not have tar in it. But if you're only doing a plane and inlay from there to there, you need to take a characteristic sample of that full depth. If you're taking it out in different layers, if you take that top piece out and then you take the second piece out, then you'll need to characterise two waste products. Because as soon as you start taking material away from a highway, it's classified as waste. So you end up in the waste industry and how to deal with it with permits and everything. And really that's somewhere where we want to avoid, because these materials can be really good construction products. And this slide, I think, is my definition of what you need to be doing if you end up with some tar in some site investigations that you've undertaken on the highway. And if you liaise with this is in a local highway authority, if you get all your waste people on board, you could get led down the contaminated land site and a remediation project. Well, the highway is not a contaminated land site, so that's not the way to go, because that's all they know about and that's the only advice they can give you. And the action of Highway Authority maintaining a road does not come under the Land Remediation Act. So it's an engineering project, and normal construction operations such as full depth planing to take out the material that you're not going to use is not mixing waste. There's some people that think they're not allowed to do that because it's deemed mixing waste. But if you've characterised the horizons, you can actually define it as a construction project. And that's what the last bullet point here is talking about. And that's where you want to get your project to if there's some tar within the road that you're dealing with. So if you pre-test the horizons, they can then have a certificate which shows that they are a construction material. And they either meet EN 131088, which is the European standard for reclaimed asphalt, or Type 4 subbase or 6F capping. And these are all defined products within the DMRB and the SHW. And in fact, the Environment Agency, which looks after waste and control of waste movement and transport and permits for treating it, actually have a position statement for our industry. And it basically says they don't need you to have a permit to treat some of this stuff. And the essence of their position statement clearly defines that the treated asphalt waste containing coal tar can meet the requirements of the different specifications and different material types within the SHW. So if you've got the test certificates from a site investigation that show it meets clause 948 or 810 to 880, it can be reused either on ex situ treatment. And there's been quite a lot of projects and quite a lot of our industry already does this. So this is not new, but it's interesting if you're not familiar with how you can work in this area. Some clients get rather confused. And they see it all as waste, and tell the contractor to take it all to tip, which is not very good for our environment and not very carbon friendly, to be honest. So within my client industry, we've tried to give some guidance here. And this is the latest 2019 version. And this link takes you straight to this document, which is freely available. And it's got everything you need to know if you're a client and you've been told there's some tar within your works. In there, it's got these statements in that the first stage is to test, to develop the scheme design. The second stage is to identify what's coming off the site, because that's your duty of care, to give the contractor prior notice of what waste they might be carrying and what waste they might have to deal with. And if you can characterise it as a product, then they don't need it. It isn't waste. They don't need permits to carry it. So it's simply they can take it as a construction product, store it and reuse it where they want. They don't need permits to transport. They don't need permits for storage. That's not normally the case. We used to do that in my authority, which is Norfolk County Council, but they had me there to help them. But the important part in the document is not to look for the tar, but it's to look at the composition of the arisings and not within the individual layers. Now, when you do get test results, there's a whole load of analysis that can be done. You can look for different suites of PAHs. You can look for phenols and other nasty things. But the quickest way to evaluate whether you've got hazardous waste or not is to look for benzoate pyrene. And that is a marker product for all the other PAHs in the sample. And as you can see here, the general rule is that if it's above 50, then you've got hazardous material. And the marker there for 50 correlates with 1,000 milligrams to kilogram, which is the cutoff. Anything below that on this side is non-hazardous and can be retreated. Obviously, if there's none at all, it's just unclassified waste. Well, it's actually a product. If there's no tar in it at all, it's perfectly suitable to be recycled. And quite often it's recycled under the quality protocol for recycling inert waste into construction aggregates. It's been around for a long time, and it's in clause 710 of the highway specification highway works. But where you've got tar, but it's not hazardous, you can retreat it. And that regulation position statement from the Environment Agency says you don't necessarily need a permit. The other way of dealing with it is simply to treat it in situ. If you don't take the material off site, then you don't create waste. And in situ stabilisation has been around for 50 years or more. And we've been using it in Norfolk County Council for 20 years, 30 years. I keep forgetting how long I've been there, but there we go. Yeah, 30 years. And the EA view doesn't affect this because it doesn't come under any waste designation or waste categorisation. And I'll go through a project where in situ stabilisation is undertaken because it's still seen by some authorities as a bit new and innovative and, do you really get what you asked for? But the paragraph at the end is quite clear. The ex situ stabilisation is the one that the EA know about more because that's the waste and that's one that comes under their jurisdiction. And they're quite happy for that to be undertaken as a role. And in fact, if I get time to go into the reclaimed asphalt guidance from the adept, there's a whole life costing exercise in the appendix of that adept guidance, which shows ex situ stabilisation with cement is the best whole life cost model for dealing with tar-bound arisings. So this is the case study of a job in Peterborough. It was undertaken by Stabilised Pavements. So they took the top layer off. They reduced the programme of work for Peterborough to 1 week instead of probably a month before. They took some arisings, kept them on site, and then incorporated them back into the hydraulic bound material. So there was no waste produced because nothing left site. And over 80 tonnes of tar were re-engineered on site. You've got to do your normal ground investigation to make sure you don't cut through any electric cables, especially if they're coming from wind turbines. And the site procedure, in effect, is you pulverise the pavement, you mix in whatever planings you might have on top, because that's perfectly allowable. If you have 2 or 3 sites, you can move the planings between one and the other. It's done a lot in Cambridgeshire, where they need to build up the fen roads. They take planings from one road to incorporate into a new recycled layer on a fen road and make it thicker and stronger. And these are all actions that have been approved by the Environment Agency locally for those projects. The binder is quite often a blended cement, PFA and cement, or could be GGBFS. And these have advantages over OPC because they hydrate a little bit more slowly, and you get a much better crystal growth in the compacted layer after it's been compacted. You get more time to work. And in fact, it gains in strength for anything for 4 to 12 weeks afterwards. You've got to check you're getting what you pay for, so you have to do some testing. The most important test, in my view, is this LWD here, which is lightweight deflectometer, where you drop a weight and there's an accelerometer in the base, and it measures how much deflection you get under that weight, and it gives you a measure of the stiffness of the layer. You record the value in a term called surface modulus, and these terms are all now in the new construction design standards in the DMRB website, 225 and 226. If you go on standards for highways, you can pick up the standard documents. They're all freely available online. And in CD 225 and CD 226, it gives a performance foundation design, and using the LWD is the crucial part to measure the performance after you've made it. So if you use that, you don't need to worry about moisture control or binder measures. You just take, the client does the testing after it's been built, and if it achieves the right surface modulus, you can sign it off. Obviously, for the contractor, they need to make sure they're getting it right, so they need to check everything goes in there properly. So this is the typical design life for some of these different types of recycling. So structural road recycling, I can verify it's 20 years plus because I've got sections on the Norfolk network which were done longer ago than that. And even when I was in Suffolk, which is nearly 38 years ago, there's sections there which were then done, and I know the road is still holding up really well. It just requires surface dressing every 5 to 10 years. So within an asset management plan, you can design this as a straightforward process to manage your assets. Typical cost comparison here. Obviously, it requires grading and recycling, and it's particularly suitable for urban environments because you don't need to take stuff away. You just need to bring in some material to water and cement. You've got quite tight level controls there, and the job is very quick, and it can be trafficked after the initial set of the bound layer, so that people can get in and out of their houses even while the works are going on with minimum disruption. So these are classic cross sections from stabilised pavements catalogue, I'm afraid, but there we are. Gives you an idea. But one of the biggest things is it is very carbon friendly. It's less than half. Well, there's a percentage there that I can't work out in my head, but it's pretty. There's a lot of carbon that's not used, and the majority of that saving is in the lorry movements, and that's the stabilised layer open to traffic before you put the asphalt on top. So it's perfectly good to use as a haul road or a road during the works. Another way of dealing with some of this contaminated material is you can reheat it on site and relay it. So there's lots of equipment these days, heated boilers that can take the arisings, you put them in a hot box or you heat them up with some gas, and then you relay them. Harry Pearl around Manchester area has been doing this for the last 5-10 years, and he's got a system that's certificated for highway use. They use virgin material, they use waste material. And again, it's very environmentally sustainable because you're taking up what's in the road and you're putting it back in it. So this is another case study using ex situ foam bitumen. You can use ex situ hydraulic bound material. And if you, again, this TRL document, PPR 2008, is freely available from the TRL website. It's got lots of case studies in to help people realise that there's no need for this material to go to waste. It's perfectly suitable for use within highway works. In Scotland, they've got the same guidance, but it's written by themselves in a different way. And the ADEPT guidance, as I said, has got some different things in there. Quite a few million tonnes of planing generated from our highway network. Utilities also create quite a lot. But the latest data we're available on the UK scale shows that we're pretty good at reusing it all. And I think whether the driver comes from the contractor, the material provider, or the client, we're not sending much of this stuff to waste. So the industry is pretty good at what it's doing. So this is just a heads up to you that don't know what's happening. There's people out there that can help you. So thank you for listening.